Sorry, share the screen. Okay, welcome all once again. We have been stopped our training session maybe for last 2-3 months. Lot of traveling, corona and all. So now, today we are discussing SSL, right? Can you all hear me?
Yeah.
Yes.
Okay.
Yeah, I can hear you.
Yeah, you can freely respond, or you can just type if you have some questions when I'm speaking, or you can just shout, no problem. So we are starting now. So you know what is SSL, or all of you, you know what is that SSL means. You recently start getting a lot of messages like this. Your connection is not private, this type of message, not secure, this, that. Why? The reason, all the browser companies, in fact, all the technology companies, they started like, there will be no more HTTP. If you remember, there was an HTTP sometimes back, HTTP sites. So it's no more. So you know what is difference between HTTP and HTTPS? Of course, because HTTP is not encrypted, HTTPS is encrypted, or the S means secure, whatever it is. S means secure. So you can see my screen, right? HTTP, all HTTP has gone. Now only HTTP gone, and it will be only HTTPS. So what was the problem with HTTP? Anyone can tell me what is the problem with HTTP? Okay, I'll tell you. HTTP is plain text. It was simple plain text. So what happens? You type your credit card, let's say on Amazon or somewhere, you are just typing your credit card number or something. And if it is HTTP, it will just pass that as a text. If it's HTTP and you are putting it on Amazon, it will directly go to it as a text. The credit card number itself will go as a text. So anyone having that text can read your credit card number. So who will be having that? It's called man in the middle. There is something called man. Sorry for my bad handwriting. Man in the middle. There was something called man in the middle. So what is man in the middle? It is somebody between you and Amazon reading. You are here, Amazon is here, and you are sending your credit card number from here to here. So there is somebody sitting here and read what is your credit card number. So it's unsecure. Okay. So what happens? You know how there is a man in the middle attack happens. What is the reason behind that? Okay, I'll tell you. Because in our company, if you are doing a trace route from here to, let's say, Google, you can see many routers here. There are so many routers here. It's you can see it's going through so many routers, so many network. It's not like internet is not like your computer to other computers. So there are so many routers. I mean, sometimes it go up to 30. If you do a trace route, it will go up to 30. So what happens? Anybody having a basic knowledge of routing or switching can just take that full packet from any of this router. Not only the router, your switch. I mean, the switch in your company, or the router that your ISP is giving, or whatever. I mean, wherever you can get, or some spyware, they all get your credit card number. So, and the internet was not designed for credit cards and all. This all came recently. So it wasn't a problem when the internet was designed. So now it is a problem. So it was a problem. So now we have to stop man in the middle attack. So what happens? You have to encrypt your credit card number. How to encrypt a credit card? Okay. So how to encrypt a credit card or whatever, encrypt and decrypt. So what encrypt SS means normally, if you say your credit card number starting, okay, let's say 2345. This is your credit card number. You want to send it to Amazon. So there are so many routers. I told you so many routers, switches, and anybody, any hacker, they will get it. So okay, so we don't want anybody in the middle. That's called a man in the middle to get it. Only Amazon should read what you are sending from here. So what you do, you encrypt your credit card number is hello. Okay, your credit card number is 2345, and you encrypt it something like a garbage number 9836 or something like that, a garbage number. Then you pass it to Amazon. Then Amazon has this key and they will decrypt it. It's again back to 2345. So anyone between the man in the middle, they will get this number 9836. It's useless for them. There is no point. It's just a random number for them. Only Amazon get it. So how you do that? That is another question. So if you want to encrypt something, you need something called key. It's just a word. You are locking something, like you lock your house and you give the key to your friend, he can open it. Other people, they cannot open it because they don't have the key. It's basic. So we call it also key. Sometimes we call it certificate. Sometimes we call it hash, whatever, but that's the name. So your credit card number 2345. If your credit card number is 2345 and you are using a key, something like you are multiplying this by, let's say, this number. You do a multiplication and then you send that to Amazon. So they have this key 23. I mean, this is, I put the same. Let's say you are multiplying by 35. And Amazon, they have this number. So what they will do, they will divide it by 35. And they will get the number. In the middle, you are not getting. It's not that simple, but you can say this 35 is the key. Okay. Now, let's say Amazon, they have a key. That key is 35. And you are the customer and you have the key. You multiplied your card number and send it to you. How Amazon will give you this key? Any idea about that? Because you don't know Amazon, and an Amazon employee cannot come and give it to you the key. And if they give it to you, you may give it to your friends and all. So this key, it is, I mean, sharing, Amazon cannot give you this key because you have millions of customers for Amazon. So I will give you two concepts on that. There are two types of encryption. One is symmetric. It's a little bit theory. I thought we will have a little bit theory because always we do practical. This is called asymmetric. I hope you enjoy that. Maybe sometimes you don't like theory. Just wait for 5 minutes. We will skip it. So it's symmetric, asymmetric. So what is symmetric? Symmetric means you have a key. You are giving it to your friend. like your house, you give your key to your friend and they come and open it. It's personal. You just keep. Like spy agencies, James Bond and people like that, they use this key. For example, I want to give a very secret communication. I always have it, Ayub maybe. So I will give a key to Ayub. He will install it there on his computer and we always communicate. That's person to person. In that case, it is symmetric key. One practical use, I will tell you, VPN, for the VPN, we are using symmetric key because it's not published. You have one head office, one branch. So on the firewall, we are putting a key in this side, other side also we are putting a key. So what happens? One VPN router here, one VPN router here, and there are entire internet in between. So we have a key here, one key here, here other key. So we encrypt traffic from here and we decrypt traffic from here. Again, back also here we encrypt. The key is same. Let's say our key is 35. We put both. Here also encrypt multiplying by 35. Here they are dividing. If we are multiplying by 35, here they are dividing. So this is symmetric because symmetric means key is same on both sides. So this key thing is not practical if you are Amazon. You are Amazon, okay, and you have 1 million customers. All of these people want to share their credit card number with Amazon. So how Amazon will give you the key? It's called asymmetric. So Amazon will give you something called public key. And Amazon will give you that, and Amazon will keep something called private key. So all of these people, entire world, they have something called public key, okay? And you know, if you have entire world, they have a key, then you must be thinking, what is the point of having a key, right? I mean, only idiots will do that, right? You lock your house and take a copy of 1,000 key and you give everyone in the Doha, right? Only idiots would do that, right? I mean, why should then you have a key? So there you have a real problem. Actually, only mathematicians solve this problem. It's a little bit mathematics, okay? It's interesting. What happens here? Amazon sending you a traffic to you, something like okay, let's say you are sending a traffic to Amazon. You want to do a credit card, right? You are sending them a credit card. Okay, your credit card number you are multiplying by 35. Here they should have, I mean, they have another key. This is very important thing to understand. Amazon has something called private key. Okay, here you are using public key, and entire internet using this public key, and you are encrypting. We say multiplication and division just for practical purpose. I mean, easiness. Actually, it's not the case. That I can give you that details. But this public key is, let's say you are multiplying by something like 13, and this public key is something like 35. So how can you encrypt something with 13 and decrypt it by 35? So this concept, there is something called, this concept, it's called in mathematics, they are using a technique called prime numbers. Prime numbers. I'm sure you learned it in 5th grade or 6th grade. Prime numbers. For example, 2 is a prime number, 3 is a prime number, 5 prime number, 7 prime number. Then it will go like 17 prime number, 19 prime number. It's like that. So if you multiply any of these 2 prime numbers, let's say you are multiplying 3 into 3 and 5. 3 and 5. So you are multiplying 3 and 5. You will get 15. This 15 can be only divided by 3 and 5. A prime number is actually, if you know what is prime number, the concept of prime number, you cannot divide it. You cannot divide a prime number.
It's like divisible by the same number itself.
Yeah, same number or 1, you can say. I mean, yeah, same number or 1. I mean, any number you can divide by 1, or any number you can divide by the same number, right? So yes. This prime numbers you can, and this prime number you may think it's 19, but there are very, very big prime numbers, like millions of digits, big prime numbers. Okay, so if you multiply 2 prime numbers, you can divide with if you say 3 into 5, 15. 15 can be divided by 3 into 5 only. You cannot have any other number. Okay, let's say this is maybe too easy. If you say 30 into 7, what is 30 into 7? 91, right? So if you get this number 91 can be only divided by 13 and 7. Okay, there are big prime numbers. So what they will do, Amazon will keep 3 and 5, and they will give you 15. So 3 and 5 is Amazon's, they have this number, and all over the internet they publish this 15. So you have to multiply by 15, and anybody in the middle, they don't know what is that private key, 3 into 5. So they will do it. They will do the math. But computers, if you use to find, because it's very easy, you can easily guess 91. You can use a simple calculator and you can find it like 30 into 7. But if you are thinking like, if it's a very, very big number, like a number with 1,000 digits or number with 10,000 digits or something, they cannot find which are the number, the private key. They cannot guess it. If they want to guess it, it will take like 100 years or something for a computer to do that. If it's a very big number, if it's small number, it's fine, because these numbers we are just doing it as an example. But if it's prime numbers, if it's now, before it was, we used to do that with the 32-bit key, then 64-bit key, then 128-bit key, 256 key, 512 key. Now it is 1024 key and 2048 key. The modern, we are getting 2048. It is like very, very huge, and you need a supercomputers, like very big supercomputers, to take 100 years to divide and find what is the public key. So it's pure mathematics. So but we cannot cover it full. But if you are interested, maybe you can learn it from YouTube or somewhere, or we can see it. Only those who are interested in mathematics, we can see it and discuss on another time. So what happens now? The Amazon, again, we are coming back to Amazon. They have a key, let's say a big one, 2281 and 3047. These are prime numbers. These are prime numbers. You cannot divide it. Okay. Then they give it you all of you, that they are giving you the multiplication of this number. What is the multiplication of 6950 207? This is the multiplied number. They ask you encrypt using this. Okay. Yes, I'm sending something. Okay. You are sending by your credit card number by multiplying by this or encrypting by this. I'm using multiply again. It's not the correct word. Encrypting. Actually, it will be like, I will just show the mathematic part of it. It will be like you, if you remember all the formulas, you have a plain text. Okay. A plain text, then you will have an encryption system and there will be a key. Then you will get an encrypted text. Okay, so this is the encryption, and the decryption, you have a D, and then you will do the encrypted part, this C. Okay, then you will get P. P is the plain text. This is the, actually this is the mathematic formula for the encryption and decryption. But that I'm not going there. So here you are encrypting with this key. This is the multiplication, and these are the numbers. So even you try to divide these, find the division of these two numbers, it's very hard to get it. This is so what happens if you encrypt your credit card number with this? Only Amazon will know that. Only Amazon will get it. Even you are doing all the packet capturing, sniffing, and span tree and man in the middle, anything, you take this thing, you will not get it. Actually, if you remember, when we used to fix firewalls, Sonic maybe 5 years, 6 years back, there was something called CFS, content filtering service. You remember? This content filtering service, we used to say, or for example, if we wanted to block Facebook, there was something like block Facebook. There was, you can just enter facebook.com. Now, if you look at now, you will not see that content filtering service, because what happens here, if you put it anything like google.com, this you see here, this one is HTTS, and anything, any device in the middle, they will not understand you are sending traffic to, I mean, your URL is Google or any of this text. They will not get it. The firewall or the router or the switch, there is no way they will get any of the text that includes URL. They will not get it. If they need to get it, they need this private key. That's why nowadays in firewalls, the UTM, in the Sonic wall, Fortinet and all, this feature is become irrelevant. They are saying now it's app. They are using the word app control and that type of things. Why? Because they are using another techniques to block Google, Facebook, and the chat site and all. Because this text, it cannot come. Some firewall vendors will tell you that they will cache this text. No, they cannot cache this text. If any firewall can cache what you are typing here or what you are typing here, then this entire encryption thing in the world is useless. There's no point having it, right? So any firewall, it will not detect any text. It will only use DNS or something like IP addresses and some patterns and all to block site. No, not anymore. Before 5-6 years, it was easy. They will just find it because it was HTTP. So they will just find this and they will just block it. So that was the case. So I just told you, because firewall, when we are installing firewall, you always ask why you are not stopping it. Simply like you cannot use. It's the technology changed. So that was just a information in between. So where we are reaching now, public key. Okay, this public key, private key. Now, if you are sending it, not the firewall, not the router, nothing is going to find it. Here in the middle, only Amazon will get your credit card, or the bank your credit card. Now you understand that you are encrypting this one, encrypting your credit card with this, and they are using this key to decrypt it. And Amazon, they will encrypt their traffic. For example, Amazon want to send their page or some key or some receipt or something to you. They actually entire page is encrypted by this private key, and you are getting an encrypted traffic. So you would ask why they encrypt, because all of us already have the public key. All of us can read that side. So what is the point encrypting this? Encrypting, because it's a waste of time, right? Waste of resource. It's not. Actually, it's encryption. These keys are not just for encryption. It's for authorization or finding the authenticity, that type of things. I'll tell you. Now we are in that point. We are coming to certificate authorities, root certificate. Again, my pen is even bad, my handwriting is even bad. Okay, root certificate, intermediate certificate. There are certificates like that. So why we need to buy a certificate? That is, let's say some fake company, they put up a server called pretending they are Amazon. Pretending they are Amazon, because internet is, anyone can put up their own server. Okay, somewhere they manipulate the DNS and getting the traffic there, and Amazon. You are getting a public key from that server, because they can also have a public key. Anybody can generate a public key, because this open SSL and all, you can create a public key. So you think, okay, fine, Amazon send me a public key. You encrypt your credit card and send that information. They open it, they find the credit card, and they take all the money. Okay. So this public key, private key concept, it's not working without somebody telling you that this is originally, it is coming from Amazon. Otherwise, there is no point, right? There must be someone we can trust should tell you that this key is coming from Amazon. That is exactly what happens if you see it here, any place, this log sign, it is coming because someone telling you that this public key is original. Let's say here, I have a site, I didn't buy, where is it? Okay. There are sites that I cannot drag it up. Okay. This is HTTPS, but I didn't buy a certificate. So if I didn't buy a certificate, it is saying like, this is actually, traffic is HTTPS. You can see traffic is HTTPS, but still it's showing not secure. Why it's showing not secure? There is a public key, there is a private key, everything is there, it's certified site, everything is okay, but it's still not secure. Why it's not secure? Because someone trustworthy is not telling you that this is originally from this company. So that trust is called, that company, they are giving you a trustworthy certificate. It's called root certificate. Root certificate. Who are these guys? If you take your Mozilla Firefox or your Google Chrome or whatever, Internet Explorer also, because I use Firefox. You can go here and find privacy and security, and you will see view certificate, and there are certificate authorities, you can see it. So it's hard coded. Actually, the browsers, when it's coming the first time, they are having it here. It's hard coded. It is there in the, when you are installing Firefox, Internet Explorer and all, these companies are already there. So they, all the internet, they assigned these companies to issue certificate, and if they're having the certificate, then they will say, okay, this company is authentic. This company is authentic. That's why then this will not appear there. This will not appear there. It will be like secure. It will say, okay, secure. This connection is secure, and you can see the certificate. Okay, who issued the certificate? The certificate issued by Google. Then there is an intermediate. I'll tell you what is internet data server, and there is a root company. That company issued trusted, and you can see the trust details here, how it is that, and that type of things. Okay. So this is Google Trust Services. They are trusting. This is the serial number. See, I mean, whenever they are issuing a certificate, there's a serial number. Why they have a serial number? Because if there is any leak or something, you can just ask to revoke, and they will revoke the certificate, and they will just say okay. And there is a validity, all of these things. And about the validity, I want to tell you something. Before, we could buy like 5-year certificates, 3-year certificate and all. Nowadays, now last year they stopped that. The internet company now saying, I mean, only 1-year validity is there, so you cannot buy 2 years or 3 years or something. It's like that. So they've done it. So you buy. So when you are hosting, when you are starting a company like Amazon, you apply for a certificate. You apply for a certificate from this root company. Then root company, what they will do, they will put another, I mean, on top, when you are accessing Amazon site, sorry, somebody knocked my door. Okay, when you are when you are trying to access Amazon, it will give a certificate. So that certificate will have some more information. That information is the root certificate. So you will cross check, because you already have on your browser what are the root certificate. So you will cross check with these people that this certificate is original. So it's like a certificate coming from Amazon. It has two information. One is Amazon public key, and the other one is root certificate public key. Root certificate, something like DigiTrust or something. There are so many, Comodo, Google itself is a company. There is Symmetric also. There are so many companies. So when you are getting a certificate from Amazon, it has this information also. So you will check both, because this information is on your browser. You will check this certificate is correct. Then you will say, okay, this is Amazon original. So you will get it, that certificate. This is a cross verification, and somehow another reputation also. So it's just like you have all the certificate information in that case. So that's one part. And now I will tell you something, because now after every company and every browser has, I mean, only accepting HTTPS. Now there is, they made it simple and anyone can issue. So there is one site called LetsEncrypt. Okay. LetsEncrypt. Okay, this company, it's authentic. It's approved by all the browsers. They will issue free certificate for you. So you don't need to buy it anymore. But the only problem is the certificate will valid for 3 months. Other certificates are 1 month, so 3 months. So you need to put a procedure. I mean, you need to write a code actually available on internet. So you can have it, you can run it on your server. So before it's expiring every 3 months, you need to update. You just need to send a signal that this is LetsEncrypt. We are using it for so many purposes now. LetsEncrypt. This the site. So just remember, if you are planning to host service, this LetsEncrypt is a very useful term, and this is not a startup or something. It's sponsored by all the big companies. So Cisco, Mozilla, Google, AWS. I mean, it's going to be a big thing. All the people selling certificate, it's no more important. So you can just take it from this LetsEncrypt, and it's everyone approve this. All the browsers support this, so you can use it. So I'm just telling you. So if you want to save some money by coming this session, so you can just save it. So now on the root certificate, so we made it like root certificate. Now what happens? There are only very few companies issuing root certificate, and there are millions of sites.
So Farooq, if we are after 3 months, what we have to do again? Again, we have to do something if we want to extend the validity.
Actually, it's a validity. You can. There are LetsEncrypt client that you can put it on your server, so it will send a renewal request automatically every 10 days before renewal. So it will send an automatic request and it will renew it.
Automatically it will renew.
Automatically it will be renewed. So you don't need to do it manually. Or I mean, if you see most of the companies nowadays using LetsEncrypt, it is. I mean, wherever you look it, even this company is using LetsEncrypt. So. If you look at here, certificate, this LetsEncrypt.org, and you can see the trust sectors here, and it's I mean, so many. I mean, even our company, we are doing this 3CX. They are using, I mean, all of it. It will be only. So what happened now? This LetsEncrypt, they are issuing millions of certificates daily. Okay. So this root certificates cannot handle it anymore because it's a huge database and you have to keep it secret. There are so many issues. So there is something called intermediate certificates. That is another headache for you. Just presenting. There is a root certificate and then intermediate certificate. Then again, maybe because there can be more than one intermediate certificate, then your public key. So when you are registering with some companies like Commodore or something, they are intermediate certificate authority. Then they will check with other, then they will check with other. So effectively, your public key will have a certificate from root for this. I mean, root will approve this intermediate. Then this intermediate will approve this intermediate. Then this intermediate will approve Amazon. So that's the process. So if you ever got a certificate from GoDaddy, because normally most of us here buying from GoDaddy. So if you are getting it, I mean, how you get it, you will generate first one private key. Private key is US. I told you what is private key. So you generate a private key. Private key will be like, I think I have a private key here. It will be like this. It's a private key. So if you remember, I told you that numbers like I multiply by 3 into 5, 17 to 19 and all. Actually, it is very big, and this is in hexadecimal. So that's why you see numbers, both numbers and the text. So this is the private key. I mean, this is that big. So that, I mean, anybody in the middle, they will just, it's just garbage for them. They don't get it. So this is the private key. So when you are asking, when we are generating a certificate, normally your IIS server, or no, because we are using mainly IIS server, Apache server, and NGINX server, and Glassfish servers. These are the servers we are using. So these servers, they have the provision to generate a private key. You generate this private key and send it to GoDaddy. Okay, they don't save it. They're claiming they don't save it, and they will issue a public key with a certificate from GoDaddy, also from their intermediate server, then the root server, all the keys. So they will send you a public key. That public key you will actually, I mean, generation of private keys is just a process. After that, you will install the public key. After that, you will install the public key on your IIS or Apache or wherever. Okay, that's the process. You install this. So if you notice, there is a bundle of keys, it will come. That is actually intermediate certificate. Intermediate certificate. You can go to Mozilla and see, here there is a main, here there is main trusty company, then there are intermediate, then there are again intermediate, like that. So you can observe this, you will see how it is working. There are 3 intermediate are there. There are 2-3 intermediate certificates. So you will get a bundle of certificate. That's the case. So you can have it. I think now numbers now the same. That's the case for the encryption. Now you have not only for the site, nowadays for SMTP, they're using SMTPS port number 465. By the way, HTTP is port number 80. HTTPS is port number 443. This is a standard. SMTPS, before it was only SMTP, we used to have 25. Nowadays, nobody using it. Everyone getting blocked with 25. But server to server communication still happens in 25. But this is the 465 is now become standard, and IMAP also it's working on IMAP or POP3 or any protocol now working on encryption. Everything is now working on, even YouTube video running on encryption. So everything is on encryption. So that part is clear. Now we have only one thing left that I promised that I will cover. That is SSL offloading. SSL offloading. Okay. SSL offloading is a thing. So if you have a server, you are the owner of Amazon, let's say you run Amazon, and you have so many millions of people accessing your company, and you put your public key. You are running, let's say, IIS server, and you put your certificate your private key here, and you give all of them public key. They are encrypting, and you are here to decrypt. So there are two things that you must notice in this case. One is the processor. The other one is security. Okay. The processor, what happens? The processor issue is, I told you, this is the most difficult task is to decrypt something. Let's say if you want to multiply 17 and 19, most of you will just do this. I mean 323. Okay, most of you will say, okay, I mean, just you will take a minute or something. But if they ask you to divide 323 into two prime numbers, you will take maybe an hour or something. I mean, it will be very hard for you. It's the same like computers and the processors. So processors will take a lot of time to do decryption. So what happens if you install the decryption process inside the IIS or Apache or something? Your processor will start spending most of its time, processor, memory, everything for this decryption process. That's why there is something called SSL offloading happens. I'll tell you what is SSL offloading. You are Amazon and you have IIS, and it is on HTTPS normally. HTTPS, and you are asking your clients to send encrypted traffic to these. No, you should not. I mean HTTPS. And then you are decrypting. No, you should not do that. What you should do, you must put something here in the middle next to that to offload SSL. Then from here to here, it is HTTPS. And here, from here to here, you send traffic HTTP. So what happens? The client sending some traffic, SSL offloading, you decrypt it, open the traffic, you check everything. Any issue, security issue, everything you check, open the packet and send HTTP to here. So your IIS server or your Apache server only will do what it's supposed to do. Deliver, I mean, do the database, do the, whatever it's supposed to do. So what it's supposed to do, not the additional process of HTTP, I mean, decrypting the traffic. That is one thing. That is the processor. The second problem is you put a server here and you allow everyone to send a traffic, even it's encrypted traffic, HTTPS. There is nothing in between. So the opening a client to your server means that you are attracting all kind of attacks. Even HTTPS, it can crash your server. It can be, I mean, it can top off a packet. It can do so many things. So exposing your server to the client is very dangerous. So what you will do, you put something behind, open the HTTP traffic and send it again. This is, so two issues are there. So one processor and two security. So this device is generally called a reverse proxy, if you remember old proxy server, or WAF, web application firewall. So these are called, this is the reverse proxy and WAF. So this is called SSL offloading, because this is a term now very popular. That's why I thought I will give that information also. So we have pretty much covered what I promised. It's 1 hour also. So we will stop it now. If you have anything to ask, or you can ask now, or you can send me email or something. It will be, that's it. Thank you very much for joining.
Hello. Hi, Mr. Farooq.
Yeah.
Sorry.
Yeah, tell me.
Ashish here.
Yeah, Ashish.
Yeah. Is this SSL, as you said, that we are buying from Comodo, and like you told us, like there is so many providers, right? And they are giving this. They are giving, as I know, that they are giving a key, and we are installing it in our hosting. Am I right?
Okay.
This is the way we are integrating to our hosting plan, right? Or our cPanel or wherever it is, correct?
Yes.
So the concern is how this like this is secure, like each company, they are creating like a bundle of key, and they are providing like plenty of customers, right? How this equation will be work?
Which equation? Private key, public key?
Yeah. Let's say I'm planning to buy one SSL from, let's say, like a domain SSL, like not wildcard, like a basic SSL I'm planning to buy. And I integrate my hosting, and let's say like I install it this key. And where this installing? Is it like installing in hosting, or is it installing in the domain? This is, I'm really confused.
On your hosting server. Generally, if you don't have SSL offloading, you are putting it on your server only.
So this key will be applicable
most
for
of the people here, they are putting it on the IIS server. I mean, most of them. I mean, most of the participants, I know many of them, they are all putting the SSL certificate in the IIS server, or on the Apache server, or on the Glassfish server, or wherever. So they are putting it on the server itself. That, I mean, you will put it the private key part onto your server, and actually you will put both. And whenever there's somebody accessing, they will get the public key. They will not get the private key. That should be very safe. They will get the public key. So they will encrypt the traffic and they will send it to you, the traffic. So you will open the backend, you will decrypt it. That's how it works. And if you are asking, it's you have a same server with multiple domain. I mean, before there was too much verification process for this. Nowadays, it's you have a DNS server, like you have one server for you are doing example.com and example1.com, example2.com, etc. You are putting everything on the same server, let's say. Okay. So you need to have private key for each of it, and you will publish it. And there are some certificates company, they will give you certificate that works for all of this. All of this, like most of the companies, they are giving simple like example.com and www. Actually, if you put www, it's another domain itself, technically. Okay. But same certificate will work on this. Some companies, they are giving star, wildcard. It's called wildcard certificate.
Wildcard, yes.
So wildcard certificate work with
subdomain, yes.
Subdomain, all the subdomains it will work. Okay. So, but generally they will give one main domain and then www. That if you apply for the wildcard, they will give you a wildcard. I mean, it's not safe. That's why by default it's not coming. So this too it will come. So if you have 3 domains, you will get 3 separate certificate bundle, and you will install it on the same server. So how they verify it? Actually, before, I mean, when the certificate things happened long before, you need to fill form and you give your...
Yes.
But nowadays, it's just, if you have a DNS pointing to this, you will get it. You will get the certificate. So the only verification now, especially on the LetsEncrypt and GoDaddy and all, they are just checking your domain is pointing to this. So if you apply for example.com, let's say, and if it's your server, use example.com. If your server CSR, I mean,
It is pointed.
if it's pointed to that server IP, that domain is pointed, they will issue the certificate. So the only pre-qualification to get a certificate is domain should be pointed to the IP address that is generating the CSR. CSR is I mean the details with the private key. So that's the only pre-qualification for this now. I think that's clear. And how they are different, I mean, how they are different private key and public key. It is actually, there are millions of prime numbers available, millions and billions of prime numbers. Actually, here, Nizam sent me details about
There are enough giants, but not enough you. There is something for the designers who place their vision.
Prime key number. I don't know. I'll share that link with you. So there are, it's a very big prime key is there. I mean, prime number is there, like millions, billions of letters. I mean, digits are there. Then you can have as many keys you want, because that much prime numbers are available in mathematics. So it's just there. So you can. So every company will give you different certificates. So it will never end. And this is not just prime number. There are some other. I just put it simplified. There are some other parameters also. There are hash also. There are many things that it attached to a key. So you will get separate key. I mean, it will not mix up. Even it's mix up, it doesn't matter, because it's going from domain to domain. There is a domain verification also in this case. So that's not a problem. Okay. Now, anybody else?
Mr. Farooq, how are you?
Hi.
Yeah, go on.
Can you hear me?
Yeah, I can.
Yeah. Thanks for your, this is very useful, first of all. Which the link I shared, actually this subject is a cryptography. It's a very huge subject.
Yeah. Cryptography.
So,
I saw that. Actually, Nizam, cryptography, it's a very interesting topic.
yes,
you know, if you start learning it, you will not stop it. Actually,
exactly. But since I am doing my, the master, so this subject it came. So now we are learning. It's now what you have done is very useful for us, and it's like almost 1 year we are doing this subject just for information. It's very interesting. Like
I haven't done this session for you masters like you. It's for ordinary people. I mean, just
now we are just starting. But the things which you have done practically, the websites and everything, we never, we are just learning the basics, and it's coming from Caesar, Julius Caesar. From that time, it's coming.
Yeah.
So it is very interesting, and practically when we are seeing it's now understandable. And just I share the link for information, but unfortunately it's in Tamil, so which I can understand little. Maybe some of your people can understand. It's Anna University, Indian University. The lecturing, complete lecturing is there.
Yeah, I think now in the computer science, all the courses they have this encryption.
Okay.
I think it was there, but people didn't take it seriously.
It's very interesting, like you said. Yeah.
Interesting subject actually.
Yeah.
So, anyone else?
Hi, Mr. Farooq. This is Louis speaking. Pretty interesting topic. Interesting, hopefully for everyone itself. So I was just talking about SSL, right? So something came to my mind regarding digital certificates also, like digital signatures also, right? Normally we do, this is more on internet traffic that we were talking about, but in certain enterprises we do, document sharing using digital certificates and digital signatures also. So usually what is the procedure, or what are the steps of verification do we do in that particular point? For example, we do use multiple PDF documents, right? And some we do use digital signatures for that. But in case somebody asks that any digital signature that has been assigned from me, and how do you verify that? In this case, you have the certificate authority and all sort of external bodies who are authorized to, tell you, yes, this is the correct certificate that you're getting in. But in the case of digital signature, how do you verify that?
Actually, this is it's in the beginning I told you there is something called symmetric certificate. Okay.
Yeah.
The symmetric certificate is used for all type of company-wise and personal communication. All. Okay. So anything, a PDF, encrypted PDF, or a SSL VPN, I mean open VPN, or something like that, PDF, any text or something, you encrypt with a key, okay, and you give that key to your colleague personally. I mean, you meet them and you give the key, or you send it by email. It's like that. So
if I can interrupt, I can just give you a small scenario, okay, if in case it makes sense. For example, I have a document that has to be signed by so and so person, and he is digitally signing that, so that sometimes it cannot be manipulated, and all those how and then when I email it to another person, he authorizes it. How can he normally when he opens it, it is whether it cannot be manipulated, but if you have a digital signature in this way, it can be. How do you verify that, whether it is coming from the right, the same person itself?
Actually, this is because your boss, for example, your boss, if you want to sign with a digital certificate, he is not the one generating that. There is something called a root. There is something called a root server. Maybe it's not an international root server. Your company, inside your company, this workflow things, softwares and all, they have a root server. I mean, basically, it's a company-wide server. They are the one. They are the one issuing digital certificate. And internationally also, there are companies, they are issuing digital certificates. Okay. So you present your document, your passport and your whatever, and you apply for a digital certificate. They will give you a digital certificate, and it is a private key. It's actually, as we explained, they will give you a private key, and you signature. I mean, you encrypt your document with that private key provided by a very reputed digital signature company, and you will give the public key to other people so they can open it, because it's and it will show on the document, because I remember we getting some certificate and all. It will show that it is signed by this digital. I mean, if you click on that, it will show that this
signature.
Yeah, this not only the signature. It will say that this particular company, I mean this digital authority, they verified this certificate. I mean this signature. I mean, it's like this internationally. It is authorized by somebody. We mentioned the root certificate. There are companies, they are providing digital signatures, personal digital signatures and all. So you can just they will verify your documents, and they will give you a private key. So you can use that private key to encrypt any document. That's that part actually.
It's clear. Yeah.
So we are done. How was the session? Have you enjoyed, and it's okay or not? Just wanted to test it. Hello?
Yeah, it was wonderful.
Yes, Parag, it was informative only.
All right.
Thank you for the session.
All right. Thank you. Thank you for joining. Have a nice day.
We'll appreciate next time if we have something more highlights on, because recently on the chat boxes we had a lot of issues. Lot of conversations related to Office 365 securities, and even a lot of spams and all are going on right now. So it's difficult to handle those as of now. So if we can have something similar, something more informative, how we can.
I ask all of you to welcome and volunteer, because many of the people in this group, they are very good in Microsoft 365. They are very good in server and all. They can
Sure.
come forward and do that. I don't know. I mean, I'm not a regular user of 365 and I don't install also.
Yeah.
Just, how can I do that? So if someone say, okay, I know this stuff, I will take a session. You're welcome. I mean, somebody hearing this can volunteer and say, I mean, there are a lot of subjects that everybody want to know, like VMware, Hyper-V, routing and switching. I mean, there are a lot of things, and we have very, very good experts in this group. I know personally, I don't want to tell the names or something, but we have very good experts in this group. They can volunteer, they can explain, and all of us can join. So if you volunteer, I just volunteer what I know. So I don't know Microsoft 365. So if someone can volunteer, send me message. So we will. I will just publish it on the group. Okay. So
I will appreciate if somebody from the group can interact on that particular topic.
Yeah, I mean, they just come and do it 9 o'clock or 8 o'clock. So just 1 hour they spend. I mean, only just take the dashboard and explain this is the thing, this is the thing, this is the thing. So we all are all right. I know certain things, so I just time to time come and I try to explain. That's it. Okay. I enjoy it actually. So I think you enjoy it also.
Definitely.
Thanks.
Yeah, definitely.
Thank you.
Thank you, Farooq.
Thank you. Bye.